Here I am with another example of superposition theorem. See, this is a little bit difficult problem because this circuit contains three sources. Now see what we are asked to do in this circuit. We are asked to calculate current through 12 kilo ohm resistor using superposition theorem. We have to apply superposition theorem to calculate the current through these 12 kilo ohm resistor. So how do we implement superposition theorem in a circuit? We have to keep one independent source active at a time, and other source will be turned off. If there is any voltage source, we replace that voltage source with short circuit, and if there is any current source, we replace that current source with an open circuit. Let's say at first I will keep this 18 volt source active, then this 10 ampere and this 5 ampere current source will be replaced by an open circuit. Therefore our circuit will look like this circuit. See, here we have to calculate the current through this 12 kilo ohm resistor. If I want to calculate the current through this 12 kilo ohm resistor, we have to know the value of total current in the circuit. The total current means the current that is emitted from the source. How do we calculate IT? We have to divide the total voltage with respect to the total resistance. So how do we calculate the total resistance? We have to calculate the total resistance between the terminal in which the voltage source is connected. See, let me simplify this RT. At first, this 6 kilo ohm and this 9 kilo ohm resistances will be in parallel, and their equivalent parallel resistance will be in series with this 12 kilo ohm resistor, which I have shown here that the parallel of 6k and 9k is in series with 12 kilo ohm, and that resistance will be in parallel with 10 kilo ohm. And this whole, if I reduce this whole branch into a single resistance, then that resistance will be in series with 5 kilo ohm resistor. See, the parallel of 9 kilo ohm and 6 kilo ohm is equal to 3.6 kilo ohm. If I add them up, then I will get 15.6. 15.6 k parallel with 10 kilo ohm gives us a value of 5.09 kilo ohm, which is in series with 5 kilo ohm. So our total RT is equal to 11.09 kilo ohm. Now I want to calculate IT. That means our total resistance is 11.09 kilo ohm and our total voltage is 18 volt. So we will get a value of 1.62 milliampere in this circuit source current. Okay, now if I want to calculate I1 prime, that means I have to apply current divider rule here. So what is current divider rule? Current divider rule is the RP, equivalent parallel resistance, divided by RX into IT. What is that? Actually we have to reduce, let's say this is A terminal, this is B terminal. We have to reduce these three resistances into a single resistance. That means I want to know the branch resistance of between this A and B terminal, and there is a single resistance of 10 kilo ohm. At first this 6 kilo ohm will and 9 kilo ohm will be in parallel and their parallel will be in series with this 12 kilo ohm, which gives us a value of 15.6, and that is our RX. Now this 15.6 kilo ohm will be in parallel with 10 kilo ohm, which is equal to 6.09 kilo ohm, and the total current is 1.62 milliampere. So we will get a value of I1 prime equal to 0.64 milliampere, and I1 will be in this direction from right towards left. After calculating the current for 18 volt source, I will keep the 10 ampere current source active. See, the voltage source was connected between these two terminal. I have replaced these two terminal with an equivalent short circuit, and the current source of 5 ampere was connected between these two terminal, and I have replaced that current source with a single open circuit. Now I have to calculate the current through this 12 kilo ohm resistor. Let's say this is our A terminal and this is our B terminal. If I want to calculate the current that is flowing through this 12 kilo ohm resistor, that means I have to reduce all other resistances into a single resistance. So how do we do that? At first look, this 6 kilo ohm resistor and this 9 kilo ohm resistances are in parallel, and their parallel resistance will be equal to 3.6 kilo ohm. Okay, 3.6 k their parallel resistance, and this 5 kilo ohm and this 10 kilo ohm resistances are also in parallel, and their equivalent parallel resistance equal to 3.33 k. This 3.33 k and 3.6 k will be in series. So I will replace these four resistances 5k, 10k, 9k and 6k with R equivalent one, which is equal to 6.93 kilo ohm. Now I will apply current divider rule to calculate the current through this 12 kilo ohm resistor, and there is a special formula of current divider rule. Let's say we have two resistances. One is R1 and another is R2. A current IT is incoming at this terminal. The current that is flowing through R1 is I1, and the current that is flowing through R2 is I2. Now how do we calculate I1? That is using that is special formula. The current that is flowing through R1 is I1. I1 will be equal to, I am calculating the current through R1. In the numerator I will place the value of other resistance, that means R2, and in the denominator I will just add the two resistances and multiply this whole fraction with total current IT. If I want to calculate the current through this R2, that means I have to calculate I2. Then I will take the resistance of opposite branch, that means R1, and just simply add the two resistances and multiply this fraction with total current IT. This is a special derivation or special formula of current divider rule when two resistances are connected in parallel. See, here we have two resistance. One is 12 kilo ohm and another is 6.93 kilo ohm. The current that is flowing through this 12 kilo ohm is I1 double prime. So I want to calculate the current through this branch. That means I have to take the opposite branch resistance, which is equal to 6.93 kilo ohm, and just simply add these two resistances and multiply this total current with the fraction, which will give us a value of 3.66 ampere. Okay, so what is the direction of I1 double prime? I1 double prime will be flowing in the indicated direction from right towards left. We are left with only one current source, that is 5 ampere current source. If I keep the 5 ampere current source active, I will replace the voltage source with short circuit and current source that was connected across this 12 kilo ohm with an open circuit. Now I have to calculate the current through this 12 kilo ohm resistor. Okay, I have to calculate the current through this 12 kilo ohm resistor. What is the current that is flowing through this 12 kilo ohm resistor? So as we are given the value of current, so we have to apply current divider rule in this circuit. At first, look at this terminal and this terminal. This 9 kilo ohm and this 6 kilo ohm resistances are connected in parallel, and look at this terminal and this terminal. This 5 kilo ohm and this 10 kilo ohm resistance are connected in parallel. So I can reduce these two into a single one and these two into a single one. The parallel of 6k and 9k is equal to 3.6k, and the parallel of equivalent parallel resistance of 5k and 10k equal to 3.33k. Now the current that is flowing through 12 kilo ohm resistor will be the current that is flowing through this 3.33 kilo ohm. That means this branch resistance is equal to 12k plus 3.33k. That means 15.33k. I will calculate the current through this branch. That means I will take the opposite branch resistance, which is equal to 3.6 kilo ohm, and this branch has a resistance of 15.33. I will just simply add them up, 15.33 with 3.6 kilo ohm, and multiply this whole fraction with the value of total current, that is 5 ampere, which finally give us a value of I1 triple prime will be equal to 0.95 ampere. I1 triple prime will be equal to 0.95 ampere. Now look at the direction of current. I1 triple prime will be flowing in this direction. Now we have calculated the value of I1 prime, which is flowing from right to left, I1 double prime from right to left, and I1 triple prime from left to right. that means I will add the currents with the same direction and subtract the current with the opposite direction. That means I1 prime, total current I1 will be in the direction of majority current. That means summation of I1 prime and I1 double prime will be subtracted from I1 triple prime, which will give us a value of 2.71 ampere. Although I have collected this math from a exam question, to validate this answer I apply nodal analysis method to this circuit, and I have obtained the same result. That is, the current that is flowing through 12 kilo ohm resistor equal to 2.71 ampere, and this is always my verified answer. If you have done all the steps clearly, you may get the result. Okay, that's it. Thank you.